Hi, welcome back to Kelantan channel. I'm Jaku Wong. Okay, today we are going to look at Kelantan trial paper in paper 2, year 2020 in the essay part. Okay, let's start. Question 7. Diagram shows the reaction between the burning metal X with carbon dioxide gas in a gas jar. So, if we look into the diagrams, okay, the gas jar is covered with the cover, and then inside the gas jar it contains the carbon dioxide gas, and then we put a burning metal X into the gas jar containing the carbon dioxide gas. So X is a metal that located above the carbon in the reactivity series. When X is burned, it is burned with bright flame and produce a white and black powder. So if we look into the reactivity series, so the metal X should be higher than carbon in the reactivity series, so that it can react reactively. It can burn in the carbon dioxide gas. So meaning that the metal X we can choose from here. Okay, it can be magnesium or aluminum. So before we look into the details on the questions, okay, I will show you one video on the reaction between the burning magnesium and the carbon dioxide gas. Okay, so the tank is filled with carbon dioxide gas. Then carbon dioxide is heavier than the air, so it stays in the tank. So if we put the burning petrol into the carbon dioxide, it will put off. So if we put the burning magnesium into the carbon dioxide gas, it will burn more vigorously. So you can see the smoke is forming on the surface. Actually, is a magnesium oxide. So here you can see the white the white solid is a magnesium oxide, and then the black color is the carbon. Yeah. So this is a simple experiment. You can see. So the equation here will be magnesium react with the carbon dioxide. So it can displace the carbon. So it forms the magnesium oxide and the carbon Okay. So this equation should be times 2, times 2. Okay, so that it is balanced. So now we continue. Okay, so suggest the metal X and name the black powder. So metal X, you can choose is magnesium or aluminum. Then the black powder is a carbon. Okay, next question. Explain the redox reaction that occur in terms of oxygen transfer. In your answer includes the chemical equation, substance that undergoes oxidation and reduction process, and then the substance that becomes oxidation and reducing agent. So 8 marks in total. So answer here, okay, suggest the answer. So point 1 and point 2, you should write the chemical equation. So magnesium react with carbon dioxide, produce magnesium oxide and carbon. Okay, so you should balance the equation. This one, oxygen, it has 2 atoms here, so this one 1, so this one should times 2. Okay, then magnesium now got 2 magnesium atoms here, so this one times 2, so that it is balanced. So they are point 1 and point 2. Okay, next one. So magnesium undergoes oxidation because magnesium gains oxygen. So carbon dioxide undergoes reduction because it lost the oxygen. It forms a carbon. So magnesium undergoes oxidation, so it is a reducing agent. And point number 8, carbon dioxide becomes the oxidizing agent. So these are the 8 points you can write in order to get 8 marks. Okay. So B, why is a metal that is located below carbon in the reactivity series? So when it is burned in the gas jar containing the carbon dioxide gas, so no change is observed. Okay, so no change is observed. So by referring a suitable method, draw a label diagrams on how you are going to conduct the experiment in order to fix the position of the metal Y in the reactivity series. So now you can draw the diagram. So this is the diagrams for the experiments to determine the position of Y in the reactivity series. So we use a crucible. Okay, then inside the crucible is the carbon with the mixture of the carbon and the copper 2 oxide. So normally we will use this one, but we accept also you can put zinc oxide, lead oxide, silver oxide, or tin oxide. Then under here you write it is heated, okay, strongly. So here I will show you another sorry, so this is the only questions okay, asking you to draw the diagrams. Okay, next. C. The following are the formula for 2 compounds of chromium oxide. Based on the formula, state the name of 2 compounds according to IUPAC nomenclature and compare how the names are given to both compounds. Okay, so you are given 2 types of compounds of chromium oxide. So there are 5 marks. So suggested answer. So CrO2 is a chromium 4 oxide, 4 oxide. So, and then Cr2O3 is a chromium 3 oxide. And because here we know that the oxide is the charge is 2 minus, 2 minus. So in other words, if you want to get CrO2, so meaning that the charge for the chromium will be 4 plus, 4 positive. So if you interchange it and then simplify, it becomes like this. Okay, this case also the same. Oxide is 2 minus. So in other words, the chromium here should be 3 positive. Then if you interchange the numbers, you become Cr2O3. So P3, point number 3, oxidation number for chromium in the CrO2 is plus 4 because the 4 positive plus 4. Then the oxidation number for the chromium in the CrO3 is plus 3. Okay. Then chromium, it has more than 1 oxidation number. So its oxidation number need to be stated in the name. So you have to put in the Roman 4 and Roman 3 in your answer. Okay, now the following is a list of 3 types of ores. Okay, bauxite, hematite, and cassiterite. Okay, so for each ores, state the methods on how the metals can be extracted from its ores. So here you have to know that bauxite actually it contains the aluminium oxide. Okay, so aluminium oxide. So where is aluminium? Aluminium is here. So aluminium is here. So we have to use the extraction. It's an electrolysis process. Then if iron, hematite contains iron 3 oxide. So iron, it is less reactive than carbon. So you can extract it by reduction by the carbon. Then tin 4 oxide, cassiterite contains the tin 4 oxide. So tin is also here below the hydrogen, below the iron. So it is also undergoes extracted by the reduction of the carbon. Okay, so bauxite just now, electrolysis of molten aluminum oxide, then hematite heating the mixture with iron oxide with the carbon, then cassiterite heating the mixture of zinc oxide and the carbon. Okay. Next question. The following is a statement related to the rate of reaction. Okay, a fast reaction happens quickly and complete in a short time. The rate of reaction is high. A slow reaction happens slowly. It takes long time as the reaction happens slowly. The rate of reaction is low. So based on the statement, step 1 reaction involve high and low rate of reaction. So this question actually, you can just mention one high rate of reaction, one low reaction. So suggestion here, high rate reaction, I gave the answer here, it would be neutralization. Precipitation also can, which the reaction is very fast. Combustion also can be accepted. Any suitable answer can be accepted. Then point number 2, low rate of reaction like rusting, photosynthesis. Okay, B. Let's look into, there are 3 experiments here. Okay, so you can see the temperature for set 1 is 30, the time taken is 60 seconds. Then concentration is 0.2. For sodium thiosulfate, sulfuric acid is 1 mole per cubic decimeter. Okay, set 2, temperature is higher. Concentration the same with set 1. Volume and concentration of acid also same with set 1. So set 1 and set 2 will be higher difference of concentration, temperature. So the time taken is shorter. Then set 3, volume is higher for sodium thiosulfate, but concentration is lower. Concentration lower compared to set 1 and set 2. Then concentration for sulfuric acid also lower. Okay, temperature same as set 1. So maybe later you will be asked on the time taken. Okay, now compare and explain the expected result using the collision theory if the student conduct experiment 1 and 2. Okay, so set 1 and set 2, we compare first. Okay, so using the collision theory, so in the collision theory, you have to know the first concept here. The colliding particles during the reaction here will be the thiosulfate ions from the sodium thiosulfate. It will collide with the hydrogen ions from the acid. So later on in the collision theory, your colliding particles need to be stated clearly. So there are 6 marks here. So suggested answer. Point number 1. The temperature of the reactants in the experiment 2 is higher than experiment 1. Then this increases the kinetic energy of the particles. Okay. Then the hydrogen ions and the thiosulfate ions will move faster. Then higher frequency of collisions between the thiosulfate ions and the hydrogen ions can overcome the activation energy. So frequency of effective collisions between the particles increases. So here the colliding particles already mentioned. So here you can just mention about the particles. Then rate of reaction in experiment 2 is higher than experiment 1. Okay. Next question. If experiment 3 is conducted, predict and explain what will happen to the rate of reaction. In actual fact, for me, this question it should be comparing to set 1 or set 2, but here not mentioned. Need to compare with which experiment. So we just try to answer it. So the rate of reaction will be decreased or lower compared to experiment 1 and 2. Why? Because the concentration of sodium thiosulfate solution and the sulfuric acid is lower. This one is mainly compared to set 1. Because set 2 the temperature is higher. Okay, now sketch and label the graph to show the rate of reaction for both experiment in A1. Okay, it should be B1. So it is comparing to experiment 1 and 2. Experiment 1 and 2. So here, actually you can get the information. Okay, so here the graph of temperature against the 1/time, the rate of reaction. This one actually is the rate of reaction. Okay, so how to get the 1/time? So you very simple. So for experiment 1, the value is, the time taken is just now is 60 seconds. So 1/60. So you get 0.017 per second. So set 2 actually is 1/50. So you get 0.020 per second. So you just sketch a graph here, at 30 degrees Celsius and 40 degrees Celsius. Okay, so you can sketch a graph if it is a linear graph here. Okay, next the reactants here, zinc with acid K, 2 mole per cubic decimeter, react with and then put in the copper 2 sulfate solution. Okay, the products will be zinc chloride and hydrogen gas. Okay, so zinc chloride and hydrogen gas. Then the temperature is higher. Temperature is higher. Okay, so 4 marks here. Table shows the data from the experiment conducted to study the rate of reaction between the zinc and the acid K. So name the acid K and state the role of the copper 2 sulfate solution used in the experiment here. So write the balanced chemical equations, and there are 4 marks here. So chemical equations will be 2 marks. So name the acid K, 1 mark. Then state the role of the copper 2 sulfate solution. So another 1 mark. So there are 4 marks. So suggest the answer. So acid here is the hydrochloric acid. Okay, because the result, the product here will be zinc chloride. So in order to get the chloride salt, so you have to use the hydrochloric acid. Then point 2, the copper 2 sulfate as a catalyst. Then the chemical equation, zinc with hydrochloric acid produces zinc chloride and hydrogen gas. Okay, next, draw an energy profile diagrams for the above reaction. On the diagram, label the activation energy with catalyst EA, and then without catalyst will be EA prime. Okay, let me check. With catalyst and without catalyst. So normally with catalyst, okay, never mind, we just follow it. Okay, so normally the student will make the mistake like this. They always shows the activation energy with catalyst and without catalyst using the way like this to show where is the location of activation energy. So actually if you draw like this, this is wrong. This is wrong. Why? Because actually this one actually is not the correct one, because it is not showing to the peak of the curve here. And then it is an exothermic reaction, so it should be an exothermic reaction. So the reactants energy content for the reaction is reactants is higher than the products. Okay, so if this is not the correct way, so we be deducts the marks. Okay, so this is the wrong one. So the correct one, it should be like this. So better we draw or label it like this. Okay. So with catalyst, okay, but here is mentioned is EA. Because normally with activation, with catalyst, we will use the EA prime, right? We just follow the questions. So if EA with catalyst, so we have to use the EA. EA, not EA prime. Then without catalyst will be EA prime. Okay, so we follow the question. Okay, then you have to remember to label the energy here, and then the reactants and the products. We have to put in the equation also. Don't just write reactants and the products. So we have to put in the equation. Zinc react with hydrochloric acid in the reactants, and products will be zinc chloride and the hydrogen gas. Okay, you are allowed to use the ionic equation like zinc with hydrogen ions, and then zinc ions and hydrogen gas. Okay, this ionic equation also accepted. Okay. Okay, next question. Diagram 9 shows two types of cell, P and Q, cell P and cell Q. So if we look into the two types of cells here, so cell P, it contains the battery, cell Q, no battery, but different electrons. So we directly know the cell P and cell Q. Cell P will be electrolytic cell, cell Q will be vortex cell. Okay, so differentiate the two types of cell in terms of type of cell and then energy change. So 4 marks here. So in here we can use the table to present the answer. So cell P, the type will be electrolytic cell, Q will be vortex cell. The energy change, so electrical to chemical energy for electrolytic cell. For vortex cell with chemical energy to electrical energy. So 4 marks here. Okay, B. An experiment was carried out in the diagrams of the cell Q using different types metal pairs. Following the result obtained. So L and G. Okay, potential difference is G 0.7. Negative is G. G and E, G also, but 1.9 voltage. Then Z and E, 0.3 potential difference. Then negative terminal is Z. Okay. So here, you have to know the concept here. Okay. Number 1, the more electropositive metal that is higher in the electrochemical series, it becomes a negative terminal. Okay. Then second concept here with the further the distance between the metals in the ECS, the higher the potential difference. Okay. So from these two points here, we can actually arrange the position of the metals in the electrochemical series. Okay. Let's try. So L and G, this pair of metals, G becomes the negative terminal. In other words, the negative terminal is higher in the ECS. So meaning that G is higher in the ECS, L is lower in the ECS. So the potential difference here is 0.7 volt. Okay, so this is for set pair 1. Then pair 2, G and E. G is negative, means G is higher. Then E is lower. You can see the voltage here will be 1.9, meaning that it will be further further than L in the ECS. In other words, E will be lower again. Okay, the potential difference here is 1.9, no? 1.9 volt. Okay. Then last one, Z and E. Z is negative, so meaning that Z is higher in the ECS, so it's 0.3. So meaning that Z is somewhere here. It won't over the L because the voltage is 0.3 only. So meaning that this one is 0.3. Okay, 0.3 volt. Oh. So actually from here you also can determine the voltage here. Okay, we see later on in the question got asked the question or not. If not, no need. If yes, we can come back here. Okay, so meaning that if we arrange the question answer to arrange the position in the ECS in the descending order means from low to high will be like this. Descending will be high to low. If ascending will be low to high. Okay. Next we look into the question. Okay. The question asks you is okay, I forgot to put in the questions. Okay, arrange the metals in the descending order. Then explain the answer. In descending order means from the higher position to the lower position. Then you have to explain how you build the electrochemical series here. So meaning that the point number 1 will be the ascending order, descending order will be GLZE. Okay, GLZE. So point number 1. Okay, there are 6 marks here, so you have to explain how you build. Actually, how we build it will be using this one. Okay, so you can mention the more electropositive metal is located higher position in the electrochemical series becomes the negative terminal. Okay, so here electrochemical series. Okay, we use we put in the bracket like ECS. So later on in your explanation, you can use the ECS afterwards because you already mentioned here. Point number 3. So metal G is a negative terminal, so it is more electropositive than metal L, and it is located higher position than the metal L in the ECS. And point number 4, metal G is a negative terminal, and it is located more electropositive than metal E, and located higher position in the metal E in the ECS. Okay, so this one is pair 1. This one is pair 2. Okay, then metal Z is a negative terminal, so it is more electropositive than metal E and located higher position in the metal E in the ECS. So this is for pair 3. Okay, then potential of metal G and E is greater than Z and E. So the metal Z is lower than G in the ECS. So this one meaning that the position of the Z, it won't be higher than L. Yeah. So there are 6 points here. Okay. Okay, so C. Based on the cell P, describe an experiment to investigate how the concentration of the electrolytes influence the products formed in the electrolysis. So your experiment description should contain procedure, result, and then the half equation at the end. So 10 marks. 10 marks. So this is question under section C. Okay, section C will be asking you at least one experiment questions. Okay, so now we look into the explanation first. Now we look into a a video showing the electrolytes of different concentration now. Okay. So in the electrolysis of 0.0001 mole per cubic decimeter hydrochloric acid, so the ions that present are hydrogen ions, hydroxide ions, and then the chloride ions. Okay. So in the since electrolytes is dilute, so ions that are selectively discharged are the ions that are lower position in the ECS. So hydrogen ions are selectively discharged at the cathode, and then the bubbles of colorless gas can be seen. So at the anode, so hydroxide ions are selectively discharged, and then the bubbles of colorless gas can be seen. Okay, so the both ions that selectively discharge at the cathode and the anode are based on the lower position in the ECS. Okay, next, if we use the concentrated hydrochloric acid, so the ions that are selectively discharged at the anode are higher position, the ions that are higher in the concentration. So hydrogen are selectively discharged at the cathode, and still the same, okay, colorless bubble gas. But at the anode there, chloride ions are selectively discharged, and the greenish yellow gas can be seen here. Okay, so these are the difference at the anode there. So once you look into the explanation, okay, now we start to present our answer. Okay, so first we have to mention about the procedure. So the procedure need to be mentioned in details. Number one, 1 mole per cubic decimeter of hydrochloric acid is poured into the electrolytic cell until it covers both carbon electrodes. Then the 2 test tubes are filled with hydrochloric acid are inverted over the carbon electrodes. Then both electrodes are connected to a battery using the connecting wires, and then the switch is turned on. Then record the observation. Then the experiment is repeated using 0.001 mole per cubic decimeter hydrochloric acid. So procedure, there are 5 marks here, 5 marks. So next, for the result, okay, so for concentration of hydrochloric acid 1.0 mole per cubic decimeter, the observation at the anode will be bubbles of greenish yellow gas is produced. At the cathode is colorless bubble gas is produced. Then for dilute hydrochloric acid, anode is a colorless bubble gas is produced. Cathode is the same, colorless bubble gas is produced. Okay, so for the half equation, so for the anode, half equation at the anode. So for the concentrated one, so be chloride ions, okay, release 2 electrons, undergoes oxidation, then produce a chlorine gas. Chlorine gas is a greenish yellow gas. Okay, then if it is diluted, so it produces oxygen gas, which is colorless bubble gas. Okay, chlorine is a greenish yellow gas. So this is the how we present the answer. So 10 marks in total. Okay, next, last question. Okay, diagram shows several uses of a kind of alkali with the formula of XOH. Okay, so it is corrosive. Let's see what is the uses. Making the detergents and soap to remove grease, as a bleach, making pepper, purifying bauxite to extract aluminium, then making new chemicals, rayon and acetate fibers, and then making ceramics. So actually, I think students should know that in making the soap and detergent, we are using the sodium hydroxide or potassium hydroxide. Okay. So XOH is a chemical substance that can be found in the chemistry laboratory. By referring to a name of the chemical substance, explain steps how you are going to prepare a solution of 250 cubic centimeter of XOH, and then 1 mole per cubic decimeter from the solid of XOH. Okay, now we look into the relative atomic mass given to you. X is 23. So directly we will know actually this one is sodium. Okay, so meaning that the sodium hydroxide. So 10 marks in this one. Actually, this question is talking about the preparation of the standard solution. Okay, so now we look into how we prepare the standard solution.
Let us prepare a 100 cubic centimeter of 2.0 mole per cubic decimeter sodium hydroxide solutions. First, calculate the mass of solute needed. To prepare the solution, weigh 8.0 grams of solid sodium hydroxide using an electronic balance. Add 25 cubic centimeter of distilled water into the beaker containing the sodium hydroxide. Stir the mixture well to dissolve the solid. Pour the solution from the beaker into a 100 cubic centimeter volumetric flask through a filter funnel. Rinse the weighing bottle and the beaker with a small amount of distilled water. Pour all the washings into the volumetric flask. Repeat this a few times. Rinse the filter funnel with a small amount of distilled water. Allow the washings to flow into the volumetric flask. Remove the filter funnel from the volumetric flask. Pour distilled water into the volumetric flask until the meniscus level of the solution is exactly at 100 cubic centimeter calibration mark. Close the volumetric flask tightly with its stopper. Then, invert the flask several times to ensure thorough mixing. Now, your standard solution is ready.
We have to mention that XOH is the sodium hydroxide. Okay, next we have to determine the mass of the XOH required. So actually we can use this formula, number of mole or times the molar mass for the XOH. So number of mole here, we can use the MV over 1000, MV over 1000. So molar mass for the XOH, so X is 23 or 16 plus H is 1, so total up here will be 40. So MV over 1000, M is not given, so we just replace with Y. So volume is 250 cubic centimeter over 1000. So times 440, so you get 10 Y gram. Okay, so this is the mass we have to measure, okay, to prepare the XOH in 250 cubic centimeter. So 10 Y gram of XOH solid is weighed accurately using the electronic balance. After that, XOH solid is put into the beaker, and then sufficient distilled water is added into the beaker, and then stir with the glass rod to dissolve all the solid. Then the XOH solution is transferred into 250 cubic centimeter of a volumetric flask. Okay, and the beaker, filter funnel, and the glass rod are rinsed with distilled water, and distilled water are added slowly into the volumetric flask until it reaches the graduation mark. Then the volumetric flask is then closed with a stopper and then shaken several times to mix the solution completely. So these are the methods that we need to prepare the standard solution. Okay, B. Diagram 10.2, 1 and 2 shows the reaction between the magnesium ribbon and the monoprotic acid. So in diagrams 10.2, 1, a small amount of the bubbles are produced, but in 2 will be bubbles produced are a lot. So you can see the difference here. Okay, so this one less bubbles means less reaction. This one more reaction. But here you have to know that the acid used here will be monoprotic acid. So don't choose the diprotic acid such as the sulfuric acid. Okay, cannot be chosen. Okay, so write the ionic equation for the reaction that occur. So no matter what is the acid used, so the ions that are responsible will be hydrogen ions. So you react with the magnesium, so it forms the magnesium ions and then produce hydrogen gas. So the gases produced in the both reaction are the hydrogen gas. So this is a ionic equation. So there are several factors that influence the observation in the diagrams. So name the suitable acid and explain the factor that influence the difference in the observation between the two experiments. Okay, actually here we have two possibility. Number one is the concentration of the acid. Number two is the strength of the acid. So in order to make ourselves easier, okay, I will suggest you to use the strength of the acid to explain the answer. Okay, so suggested answer, I will use the strength of the acid factor. So point number one, diagram 10.2, 1 is the ethanoic acid. Then diagram 10.2, 2 is the hydrochloric acid or nitric acid. Okay, so we use the strength of the acid factor. So here next, the ethanoic acid is a weak acid that ionizes partially in water, produce lower concentration of hydrogen ions. So you can write the equation. So you ionize to form the hydrogen ions and then the ethanoic ions. So hydrochloric acid is a strong acid that ionizes completely in water, produce high concentration of hydrogen ions. So hydrochloric acid produce hydrogen ions and then the chloride ions. So the concentration of the hydrogen ions in hydrochloric acid is higher than the ethanoic acid. So the volume of hydrogen ions produced in 10.22 is more than 10.21. Okay, so I will suggest you to use the strength factor. So in order to get the 8 marks easier. Yeah. Okay, so that's all for the explanation for the essay questions in Kelantan trial papers year 2020. Okay, so thank you for your time.